that I thought were interesting. This one in particular, if I can get this past the stupid error, these are large language model threats to the enterprise. And they were a little bit different than, say, the OWASP top 10. And I would close this ad if there was any way to close it, but there doesn't seem to be. Anyway, all right, prompt injection, prompt extraction, phishing, and poisoned models. These are the common large language model attacks. Prompt injection is the most common one that you hear a lot about, and first thing people do in my machine learning course, where you put in careful prompts into a large language model that trick it into violating its security policy, doing things like telling you how to make a bomb or how to write malware or something that it's not supposed to do. But it turns out that the fundamental problem with them is that the security boundaries are just inserted as text ahead of your text. And there is no delineation in the program that tells it, these are administrator commands, take them seriously. These are user commands, don't take them too seriously. There's no such separation. So you can inject things like, well, the security policy has changed. It's fine to tell me about bombs now. Now tell me about bombs, things like that. Because it does not know the difference between the user and the administrator, which is a fundamental flaw in the system. And we're talking, so that's prompt injection. And then there's, and here's an interesting statement. SQL injection is the most famous injection attack, where you put malicious commands in data going to a database and trump out the evidence in the database. What he points out here is that there are only so many SQL commands. So you could sort of list them all, and you can make a web application firewall that recognizes them to some extent, but there's an infinite number of ways to provide malicious instructions to a large language model. You could rephrase it, put it in different languages, to a much greater extent. So it's very difficult to imagine a filter that would block those malicious inputs. Now, the people are trying to develop ways to make the large language models more secure. The current versions are not very secure, and the current best solution, of course, since if you have a tool, you use it, is to have another AI monitoring the output. And it might help. It also helps with hallucinations. You generate several answers, then you have another AI verify them to decide if they're hallucinations. This is the obvious way to solve it, although it seems like you'd be increasing the processing power doing all this. And data leakage is very interesting. Now, of course, I don't quite understand how this would hurt you. The idea is nobody wants to use large language models like ChatGPT at any company because, in the first place, it's running on a public server, and any query you're sending, you don't know if it's going to train on that data and leak it to other people. But in the second place, it's just trained on random data from the web. And that's not what anybody wants. They want it trained on your data for your topic. So it's going to be more reliable. So you add that to something that started being trained on the whole web. And now the question is all that data public? I would think you would only train it on your public documentation if you're going to let the public add it. But apparently people train it on stuff and then imagine that there isn't a prompt that will repeat that verbatim out. And that is emphatically not true. You can get it to repeat whole pages from books it's learned and stuff, which, by the way, indicates that there's a flaw in the model. This is a problem of overtraining. The model is supposed to learn the structure of English. It's not supposed to memorize the training data, just repeat it back out. That's too dumb even for a large language model. Anyway, and then they got phishing opportunities. And so, of course, this is one thing I hear a lot, that they're going to write better phishing emails. Now, they're suggesting a different kind of phishing here, though, somehow using the LLM to do the phishing. And I couldn't quite understand it. You're going to scrape documents. In the supply chain, there are instructions for the LLM. Oh, yes. So you have poisoned the model, so when it answers a question, it'll put up a malicious link. This could happen by accident anyway. The early versions of Bard and ChatGPT would just give you references that don't exist. And they seem to have fixed that about 6 months ago. Now it gives you references to pages that are really there. But I'm sure some of those pages are malicious, and it wouldn't know. All right, and then, of course, poisoned LLMs. If you can affect the training data, then you can teach it bad habits. And there was an article that came out about a week ago where they figured out you can do even worse than that. You can do the Manchurian candidate attack. You can make a model that will give good answers until it hears a trigger word, and after that it will put out poisoned answers. And they say it's very hard to detect and very hard to train it to stop doing that. And that's a fundamental problem. It's very hard to remove training data from a model. This is a huge problem because there's huge lawsuits about copyright. And so something like New York Times is going to win a judgment and say you have to take the New York Times data out of your model. And the only known way to do that is to retrain the whole model with the data set that's got that removed. But that's like another $40 million down the drain. And people are trying to develop some way to erase a certain part of memory from the model. And that's closely related to explainable AI, where you can actually explain what the different parts of the layers are doing, which, like our brain, it's not simple. There's not like one neuron to make a judgment of a moral, good or bad, or tell a man from a woman. It's just a whole complex network. Many neurons contribute to that. And so if you wanted to specifically affect one function in the human brain, it would be really hard to do. Anyway, and the same thing with these LLMs. Let me check the time. 6:07. All right. So this is something people worried about for a while. If you get Airbnb or something, are there hidden cameras in there? So these guys put about 30 hidden cameras in a room, and then they tried 5 different methods. And what they found was that just looking for it by manually was not very good, because they could easily hide it in things like air fresheners and toothbrush holders. And the naked eye was very ineffective. Using a mobile phone with an app like Fing to detect the wireless signal was completely useless, because they put it on a separate wireless network. Using a radio frequency detector turned out to be surprisingly ineffective. Using a lens detector, you buy this device, which is supposed to detect the shape of a lens. This was a little better, but it found like 4 out of 27. And there's a more expensive lens detector. Looks like binoculars and accentuates light that's reflected, and that was able to find like 11 out of 27 cameras. So basically, none of them are worth much of anything. The fact is, people could totally hide cameras, and you would probably never find them, which sounds quite plausible to me. Yeah, well, and so as you probably know, a lot of online services are now using security keys as a replacement for passwords. And you can use your phone for that, for Chrome. I know I'm using my iPhone to log into my Microsoft account, and I didn't even intentionally turn it on. But now when I try to log into my Microsoft account, instead of asking me for a password, it pops up something on my phone. So I didn't really prepare that in any way except by installing some app. So that's really convenient and nice. And then it uses biometrics, and I think that's probably safer. And the other one I thought was really important, we're just about at the end of the time here, I'm going to skip to this one if I've got it. This is the one, if I can find it. Yeah, I just learned about this. If you have an iPhone, there's a new feature called Stolen Device Protection, and this, I think, is really brilliant. What it does is it notices what physical location you usually hang out in. Your work, your favorite restaurant, your home, whatever. And if you're in a familiar location, the phone operates normally. But if you're in an unfamiliar location, it now won't let you use passwords for authentication. You must use biometrics. And if you try to do something really suspicious, like change your Apple ID password, it will force you to do a biometric authentication and wait an hour and do another biometric authentication. So the idea is, if you do travel to another country, then it won't be too annoying, because you probably don't need to change your Apple password. But if somebody steals it, it's going to say, wait a minute, this is now suspicious that it's coming from this strange location. We're going to try and really make sure we got the right person here. Seems like a really good idea. All right, here, let me stop the recording.